Yes, sir. We are live.
All right.
Okay.
So first of all, thank you for having me here in the data series. I would like to just give a brief introduction about myself. My name is Harshal, and I'm a data engineer at LTI Mindtree. I've been working to create data systems and data analytic solutions since more than 6 years now. Um, my job is to build like data systems mostly on the cloud. I'm specializing in Azure cloud at the moment. I've also worked with the other cloud providers like Amazon and Google to build and deploy machine learning models. Primarily, my focus now is to build data pipelines, and I'm focusing on my role as a data engineer. That's bit about professional side of me. Apart from that, in my free time, I like to design logos. Um, I feel it's gives me a creative space to sort of unwind. And yeah, so that's just a little bit about me. Let's get started. I'm hoping you all can see the screen. I would just like to take a second here. And I apologize for any noise that's not in my control at the moment. So please excuse me if you feel so. All right, I'm just gonna stop my video for a while. All right, so let's get started. I think it will be good to start with a simple real life example of something we do every day. All right, so coffee, that's something very usual for everyone, right? So what actually goes into a cup of coffee that you drink? When you drink a coffee, it basically just starts with coffee beans, right? But can you directly consume the beans? No, right? For it to be processed or to be used, it has to be ground into powder. Now, the powder can be of different variations. For example, it can be a fine ground or a coarse grind, right? But the powder is something that you can use. What you typically do is mix it with like water or milk, add sugar, and make it into a beverage. And you have certain tools at your disposal to do so. Some of them, like maybe a French press, or if it's your liking, you would prefer a pour over. Anyway, uh, ultimately, you get the beverage, which is a consumable product. So, coffee, when it starts with beans in its raw form, is not consumable. As a beverage, you can consume it after it goes through a series of steps. So, similarly, it is like that with data. The data is not really useful in raw form as it is mostly unstructured. Once it is extracted, processed, or transformed, it is made into consumable data. And that's typically what data engineering is all about. So let me throw at you a scenario. Let's say you have an e-commerce system that records the sales of books, right? So in that e-commerce system, you will have multiple books listed and from multiple authors. Users will typically log in into that website and order what they need. So imagine that there is an application that gets all this input from the users and stores it. The inputs can be the information about which books a particular user is searching for, or it could be the output of the sales that has happened to that e-commerce website. And a lot of information really. Now, the application is a data analytics application. Let's say it's a very basic application. What would typically happen is the data would be stored somewhere, and there would be a data engineer that's building certain graphs or visualizations on top of that data. Now, this is a very simple application. But what happens when the amount of data actually increases, and that happens very fast? So that's where the data engineering comes in. Earlier, if it's a manual activity, it's not really going to be robust and maintainable. So let's say the application now grows into an automation workflow. So the data engineer decides to build a ETL pipeline to load it into a simple database. Now the database is what we call as a transactional or a OLTP. So every record is basically like a transaction that's happened on the system. So in the first scenario, the reports or the visualizations will be built on the data that is stored in the transactional system. There are lots of BI tools that can be used for this, but yeah, basically the end goal would be to generate an interactive dashboard. Now, this seems simple enough, right? The information from the website is being displayed on the dashboards or reports. Only thing is that this process must be repeatable on a schedule. So there is a series of steps that are going to be followed. And once the automation is done for this, you can call it as a basic pipeline. Okay, so there is a caveat though. As the data increases, the transactional database would really not be able to perform efficiently, as it's just meant to store data in a structured or relationship sort of fashion. So the application has to change the way it is working. To overcome this, let's say that a data warehouse is introduced as a data store. The benefit of a data warehouse is that it is really efficient for analytical processing as compared to a transactional processing that happens in the databases. Couple of things that happen in the data warehouse is that everything is structured. You have very specific relationships between the tables that are in the data warehouse, and ultimately the data warehouse has to be a trusted source of information for anyone who is going to generate reports on that. An example of a data warehouse can be a library in which the books are neatly classified into sections according to their genres. So if you want to find something, you have a criteria to find it, maybe using the genre, or if you have a specific author in mind, you can search by that author. And that's the main use of a data warehouse. Let's say the product teams, they want to observe customer behavior. They just ask a question to the data engineer. How many users have maybe looked for a particular author? In that case, the data engineer would have to run some scripts on the data warehouse and filter the data by the author name or something. So that's where the data warehouse comes in handy. Now, there is another scenario. This is where we are actually just building reports, but there can be another scenario in which a data scientist comes into picture. Now, a data scientist is actually someone who investigates the data and derives insights from it. So there is a requirement for a data scientist though, because the data warehouse is always going to be limited in the variety of data that it has. Because in the first place, we are making sure that only what needs to be there for analytics is there and it is neatly structured. But for a data scientist, uh, a vast variety of data is actually required. And I think there's somehow a data lake comes into picture. So what a data lake is, from the term lake, you can assume that like a real lake has so many types of fish in it, and it is not really in any structured way. Similarly, a data lake has vast amount of data, but it is highly unstructured. So these are the typical storage systems that can come into picture for this application. But what is common amongst all this? The common thing is that there is a constant need for supply of data. If a data scientist has to perform certain analysis, he's highly dependent on a data engineer to provide that data. And for typical machine learning applications, I'd say 70% of the job is to get the right data and have the right data. On the screen, you will see just the scenario that I've explained. I'd like to walk you through it. Starting from the source systems, the source can have multiple types of data. Maybe it is coming from a database or an API. Maybe the user inputs are being recorded through a CRM, or if it's really important, then there could be sensor data or live data that is feeding in from IoT sensors. So all this data is going to build up to be the source for any application. Now, what is a pipeline? It's just a set of tools or techniques to process the raw data and transfer from a source to a destination. It depends on what kind of pipeline you need on various factors. Firstly, you have to ask the question, what do you need the data for? Is it required for a data science application or business analytics application or just plain reporting? Based on that information, you take the first step. All right. So there are multiple considerations that go into designing a pipeline. Just hold on, please. I'm getting a message from Analytics Vidya. Okay, never mind. So I was saying there are multiple considerations that go into designing a pipeline. The first is to understand the data domain. By data domain, based on the nature of the business, the data domain is going to be different, right? Let's say you have healthcare or pharmaceutical data, then you might have a particular sort of information about drugs or sales of those drugs, etc. If you are talking about a supply chain application, then you have logistical data, that's the goods moved or shipments and tracking those shipments. So based on the data domain, you have to actually map the relationships of the tables, and also it helps in identifying which types of data sets you need. If you don't understand the data, then you won't really understand the terminologies that are required, and uh, you might not be able to build the data model correctly. So that is the first consideration. Um, and there are a couple of data ingestion strategies that you can actually apply, divided in two broad categories. They are called incremental loads and full loads. So an incremental load is when you are loading the data in pieces, in bits and or batches, and you typically need some sort of identifier to find that batch. Whereas in a full load, you are just taking the source and loading it as it is into the storage system. And if it's on a schedule, then every time the pipeline runs, the entire data is loaded. Uh, the ingestion strategy actually depends on our requirement, but if we're talking about really systems that have large volume of data, then you might want to go with the incremental strategy, because it might not be viable to load the full data every time. There are certain cases in which you load data from flat files or like CSVs or Excels, uh, which don't really hold that much data. So you can afford to do a full load on them without actually affecting performance. But for majority of the cases, the data volume can be quite huge. And you need to make sure that every schedule that you're running the pipelines, you're getting the small batch that has been recently added. So in that way, you actually maintain the history of the data as well, but keep on adding the new data that's getting added. And that batch can be as big or as small as you want it to be. Um, so that brings us to the third consideration, which is the type of processing that you want to do. Now, there are typically two types of processing. The first is batch processing, and second is real-time processing. This just depends on the nature of data that you have. If the data is coming from, let's say, a database or data warehouse where data gets added in batches or periodic snapshots, then you want to process it according to an incremental way. But in majority of IoT applications, the data is real time. Every second some data is getting generated, or every minute a data is getting generated. Then in that case, you need the application to be low in latency, which means as soon as the data arrives in the source, you need it to be able to reflect in the final report or analysis. But in batch processing, it is not the case. Typically, you will have a 1 day or 2 day lag between the ingestion or incoming of data in the source and it being reflected in the reports. The fourth consideration is actually the type of storage that you want to use. Now, as I mentioned, you have transactional databases, then you have data warehouses for analytical processing, and data lakes. I think that we can classify the data storage into these three broad categories. There are really a lot of other storage options as well. So depending on the nature of uh, the analysis that you want to do, you really have to decide which storage you want to use. For a data scientist, a data lake is a good data storage option. For simple analytic or business intelligence applications, transactional database should be enough. And for sort of big data analytics or making complex queries to result some output of some investigations or analysis, then a data warehouse is much more suitable. So it just depends on the business use case and the end analytical impact. There are a couple of tools to do all this, including the scheduling of the pipelines or sort of managing the workflows. But this session, I'm not really focusing on making it tool specific, rather principle specific. But just for your information, there are workflow management tools like Apache Airflow that actually manage the dependencies between the steps that you need to follow in a pipeline. So you can say that's a majority of the purpose for it, to keep the things running on a schedule. But if we talk about cloud services, for example, Data Factory in Azure, it comes with all these things inbuilt. So you have triggers for schedules, and you have the management inside the service itself. So it's up to us really what tool we want to use. And there are some monitoring and governance tools as well. In the diagram that's on the screen, the steps that are being followed, typically I want to highlight what an ETL is. ETL is just a type of a pipeline. So a data pipeline or data ingestion is a broad umbrella. Really, if we talk about data scientist's role versus data engineer, a data scientist role is much on the side of investigation, and a data engineer's role is focused more on building stuff. So ETL or ELT, these are the two patterns of data pipelines. ETL standing for extract, transform, and load. Now, extract means getting the raw data from the source systems. Transformation means moving this raw data to a temporary storage, maybe performing some operations on it to transform it or reformat it to make it more usable. And loading means loading the reformatted data into a specific storage. So these steps are highlighted on the diagram here. I'll move to the next one. Okay. So this brings me to the topic for my session here. I want to discuss the principles that make a good pipeline. Now, there are multiple challenges that happen when you are building a pipeline. The first being data corruption. So the data might get corrupted actually while you are loading or it is in the transfer process. And to solve that, really, the pipeline should be reproducible in the sense that, let's say the first time you load, it actually corrupts the data. You fix those issues, but ultimately when you run the pipeline, you get the same results every time. So that ensures that you have the correct logic in place. For this, the incremental loading pattern actually helps in a way that you can have an upsert process being involved while you're loading. So upsert means updation and insert. Also, it has addition of delete if you want. So what happens in that case is, let's say if your data got corrupted when you loaded it, if you had an upsert mechanism in place, every time you get or try to load the same data again, if that data exists in the target system, then it is just updated with the new values if there are any changes there. Or if it's a new value, then it gets inserted. Sometimes there are scenarios in which the transactions or records in the source system are deleted as well. So if that is the case, you may want to delete those in the target system as well. It could be historical data, so it's not really a real time here. The second issue that mostly happens all the time is data quality issues. So data coming from the source is not really up to standard sometimes, and it is not going to be useful if you even load it. So I wouldn't say that data engineer is responsible for the data quality. So if you do observe some data quality issues, then it needs to be reported back to the owner and fixed and then only loaded. But what as a data engineer we can do for making sure that data quality is good enough is that we can have a validation function at various stages of loading. So at the extract stage, the validation, you can have a validation function that returns a subset of the data according to your function, and you can observe that later. So let's say you have a function in which you are checking if the counts of specific records are enough or not. Um, and many other scenarios that you actually, these will be custom scenarios. So a validation function having at the extract stage will actually help you to make sure that data quality is intact. And if there is a issue in data quality, it does not translate or it does not flow through the system, because ultimately, if the data needs to be analyzed, um, the end user will not know if there were issues, right? So the best possible way to avoid that is to stop it from ever happening. If there's issue in the data quality, we need to stop it right there, get back to the data owner and fix those issues, and then continue loading. One of the challenges for a pipeline really is the SLA or time foundation that is there to, for example, if you are doing daily loads, then you need the data to be available at a specific point of time, so that if the reports or something being generated from that data on regular basis, then the data is available for that. So um, there are many ways. Of course, you can increase the performance of the pipelines or reduce the batch size if it's actually taking a lot of time. So it's up to us how to manage the time SLA of the pipeline. But it comes down to monitoring, I would say. If you constantly keep monitoring how much time your loads are taking, then you can optimize them better. Maybe if it's on a database, then you can create indexes to speed up the queries, or you can probably partition the data so that you query a specific period of time or a specific batch. Another issue is loss of data while you run the pipeline. So let's say there are 100 rows of data that are being loaded as a batch. When you run a pipeline, you need to make sure that all the data of that batch gets loaded into the target system. If any of those records do not get loaded, again, the final output of the analysis will not be correct. To make sure this happens, you need to have a restartability factor in the pipelines. Restartability means that either manually or through an automation, if a loss of data is observed, the pipeline should be restartable from the point that the loss of data occurred. And generally, the orchestration tools or ETL tools will have this option to do a manual load. But if we're talking in terms of automation, then you need to have a logic in place to identify if there was a loss of data. So the validation function that we used in the extract phase, there can be a separate validation function at the target system to check whether the source and target systems are consistent. Another thing we need to make sure is failure handling. Now, of course, any system is not always fault tolerant, right? There can be failures or various types of issues that are not anticipated or really unexpected. So for this, really, The solution is to constantly monitor the pipelines, and based on that, you can generate alerts. If a pipeline is failing, the data engineer needs to be alerted so that appropriate action can be taken or the issue can be identified. There are really this is probably the most frequent occurrence of issues that happen. So alerts would actually just help us in being proactive and making sure that we can go back and check what happened, where it went wrong. Another thing to make sure is we log each and every step of the way. So if data is being loaded, the number of records should be logged. If we are following particular steps, the sequence of the steps should be logged. So if some step got missed, then we can actually check or go back into the logs and see where it went wrong. Generally, metadata tables are used for this. So that really helps in just overall logging for us. The metadata information could be anything from table information, the number of rows, the time it took for those rows to be copied, what was the timestamp at which some particular operation happened. All these things should be logged. And once you have a logging system ready, you can actually have automated queries or scripts to return back in a meaningful way the output of what happened. Excuse me, I just need to get some water. Okay. And finally, traceability. So traceability is actually a very common challenge. By traceability, I mean that in real life scenarios, there are really too many steps that are being followed. It's not really that a single pipeline is in action. There could be multiple pipelines in action that have multiple steps being followed. Each of these steps might have dependency on the previous step. So if an issue comes anywhere in the pipeline, it needs to be traceable. To make sure that happens, the best practice is to make the flow of data one directional. Because if, let's say, there are multiple sources that are being loaded and then transformations are applied on those data sets, it is going to be very difficult to have a clear understanding where it went wrong. But if you have a data lineage, which is one directional, you can be sure that if something failed, you can go back to the previous step and see what's happening there, why the issue occurred. If it's not one directional, then it's really going to be messy and going to take time to identify the root cause. So these are some of the design principles or pillars of good design that one should make sure that are being followed while developing any data pipelines. So I think I am at the last stage of my session here. Coming to the next slide, I just want to draw a similarity between the first example of a coffee being consumed from coffee beans to the beverage and how it translates to the principles here. So if you look at the example, you can see that you have data in many different formats. So there can be multiple sources. It could be a database or API, or it could come from like web scraping. And the data could be in lots of formats. For example, it could be a JSON data or XML. Sometimes it could be flat files like CSV, XML. So that's the variety of data sources and formats that you have to work with. The ultimate goal should be, how can I make a simple process that is maintainable? It's very easy to build complex systems that don't get you anywhere, but it's important to make a simple process that is maintainable. So the same raw data that you are actually using should be stored always and not deleted. So it becomes the ultimate source of truth for the application. Ideally, you should have a transformation layer which is separate to the loading process. So you can make sure that while loading happens, you maintain that all the raw data is stored in a place, not deleted, and it becomes the ultimate source of truth for you. And a transformation layer separate from that loading process, where you have uh, really all the business logic implemented, etc. So a couple of things I'll just leave you with here today is, for any data engineer, it is very important, firstly, to understand the data. According to the data, you need to apply the steps that you're going to follow. Always keep the data in the raw form, preferably in a data lake, because the extraction really happens one time. The transformations can happen multiple times. So you need to make sure that the raw data is intact and never deleted. As I mentioned, you should always keep the extract and transform phase separate, and just try to make a process that is simple and maintainable. And I think that's all I had for you today. And my time is also up, so maybe we can
Thank you
start.
so much, Harshal sir. Before we proceed to answer some questions raised by our attendees, I would like to request the attendees to please fill in the poll about feedback, as it helps us to conduct more such sessions. The feedback poll is just a second, live now. Okay. Sir, can we take few questions? We have few questions along the way.
Yeah, let me see, please.
Okay. There are two questions in the Q&A section. And there were few in the chat section.
Okay. The first question is, can you please explain what E and L means?
It was E&L in your presentation, one of the slides.
Yeah, I think I covered that, right?
Okay. Sure.
It's extract, transform, and load. So E and L is extract and load. Second question is, for client sales forecasting, what should be the requirements to be kept in mind for data collection? I'd say for forecasting, you really need to have time series data. So the data collection is going to be majorly historical, and there so sales are like definite transactions, right? They don't change. Once a sale has happened, it will not change. It will just be recorded. So change data capture is not really going to be required in the collection phase. So what you need to make sure is that a transactional database would be better for data collection as storage option, I'd say. Does that answer your question? Okay.
Hopefully, sir.
It's gone from the.
Yeah.
ADF versus Databricks cost. Okay, so Databricks actually works on Apache Spark. It is, to be honest, quite effective. But if we're talking about ETL tools or ETL service, then Data Factory is a much more complete package. In terms of cost, both are working on a compute. Okay, if you are talking about a cost, then there is always going to be corresponding compute that you are using. So in Databricks, you can scale the compute to your liking. In ADF, you have more of a serverless compute. So uh, it is really pay per use. Whatever compute you're using, the ADF will charge you for that. But in Databricks, it's up to us whether we want to have a higher cost or like a higher compute uh, available. So accordingly, the cost will be more in Databricks, I would say. There's a question, why will there be data loss? Data is extracted and sent to target systems. Does ETL cause loss of data? No, of course, ETL doesn't cause loss of data, but the, of course, there can be breaks in a process, right? Something can always go wrong. So let's say if you are loading 1,000 rows in a database, there could be a scenario where your query times out or there's a connection break. Although in Data Factory, you will really not have much of a, you can set the timeout, but there is possibility that the connection breaks. So it will count as a transport level error. And once that happens, the query will stop right there and not like any more data will not get loaded. So yeah, there can be data loss. Of course, it is not a wanted thing to happen, but it does happen a lot. So we need to be mindful of that. Give me a second to read the next question. Okay, it's sort of a big one. Just give me a sec.
Sir, actually, the attendees cannot see these questions, so I'll read it out for everyone, and you take your time to
Please answer.
answer.
Please read out the question from Kaushik Day.
Yeah, exactly. So the question is, there are many tools and framework in data pipeline. How we can automate the process? Can you also please tell data engineering is responsible for apart from data pipelines and other which tasks? To get a job as a data engineer, what should be the actual learning path? Any non-IT educational background folks can enter into data engineering role, or only BTech and MCA students only eligible?
That's actually quite a good question, I would say, still, because uh, data engineering as a profession is becoming really broad now. So data engineers is not just responsible for creating ETL pipelines. Now we have to uh, own the responsibilities of a data modeler, sometimes even a database administrator. Then you need to have data warehousing experience as well. So I wouldn't just say that data pipelines define a data engineer, but yeah, it's ultimately the bread and butter for a data engineer to make data available for use, right? But I would definitely say it's like a broad umbrella now, and many roles come into it. To get a job as a data engineer, I'd say the most important learning would be SQL, because most of the data stores are uh, transactional, and SQL is actually a really good tool. It's easy to understand. Even the consumers of data can run simple queries that can output any like result for them. And it hides away most of the complex logic that happens. Whereas if you want to do it using Python or something, then you are really writing more code. So SQL gives you option to make it all easy. It seems easy and much more effective. But that is, of course, in the case of like relational databases. And now there are no SQL databases as storage options as well, like MongoDB. So they also work with scripting languages. You can query them. So I'd still say that in terms of learning path, one should start with SQL because that's going to be used the most. And anyone really can be data engineer if uh, the requirement that you basically the requirement that you should focus on is that you need to build stuff from the start. So things are not always going to be uh, according to your liking, or things might be raw. So you should have an attitude where you are building stuff from the scratch, and then if it's something that's interesting to you, then you can be a data engineer. I don't think educational qualification like should be limited here. There's, I think, a follow-up question. Where will the query be? Please explain query loss. Okay. When I was explaining the loss of data, you should know that, okay, so it's not always the case, but yeah, you do specify queries to load the data from a source. Let's say if you are loading data between similar type of systems, which is from one database to another, then you will have to query it, right? And that can be done through the ETL tool. There are options to run stored procedures or scripts to filter the data while you are extracting it as well. So there can be loss of data there, and queries can fail. Difference between OLTP and OLAP. Okay, so OLTP stands for online transactional processing, and OLAP is analytical processing. As I mentioned, it is the requirement on which you decide if you want a OLTP or OLAP system. If you want more of analytics or business intelligence queries to be run on a set of data, then OLAP is actually better because it will return the queries faster as it is more structured in there. And if you want a typical but robust system that maintains each record as a transaction, then you can go with OLTP systems, but it will not give you the performance that you need for analysis. Any suggestions to learn data modeling? There is actually a book by Ralph Kimball. It's called The Data Toolkit. It's, I would say, the Bible for data modeling. I think you should refer it. Answer to Kaushik. Are these terms, Databricks and Data Factory, specific to some cloud platform or general term and just implemented differently on different cloud? Yeah, sorry about the confusion if there is any. Databricks and Data Factory are, so Data Factory specific to Azure cloud, but each of the cloud providers will have their own similar services, but implemented by a different name. So sorry for the confusion, but yeah, it's specific to Azure. There is a question about Kafka in the CAP theorem, which attributes Kafka follow. I sincerely apologize, but I don't think I'll be able to answer this question. I've not really used Kafka much. So excuse me, but if you want, I can get the answer to you separately offline.
Yeah. So I have shared your LinkedIn profile. Few are asking. Okay, sir, we can conclude, I suppose, now. We have taken most of the questions. Okay. So thanks a lot, Harshal sir. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I am sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Thank you so much. I hope so too.
Yeah, thank you.
I hope everyone sort of learned a little bit. I tried the session was not very technical, but starting with a sort of principalistic approach to designing better solutions.
Yeah, sure. For those who are asking, the LinkedIn profile of Harshal sir in the chat is in the chat section. You guys can check that out. So I hope you guys have filled in the feedback poll till now. If not, please do it. And if you wish to conduct a webinar or facing any difficulty in registering for any of the upcoming sessions, please contact us at datahour@analyticsvidya.com. The recording of this session will be available on our YouTube channel within 2 days, and the link for which is in the chat section. So you guys can check that out as well. And there is a link for upcoming DataHour sessions as well. We have a session today at 3 p.m. So you guys can check that. And this is the link for YouTube recording. Okay, then we'll be back with another session of DataHour today at 3 p.m. The link is in the chat section. Till then, bye-bye and keep learning. Thank you so much.
Thank you, everyone. Bye.